5, 4, 3, 2, 1. The calculus class has gone on a trip to explore the calculus of amusement parks. Should we do that? Should we take a field trip and go to Valley Fair at the end of the year?
Yeah.
Okay.
No, I hate Valley Fair.
If the bus leaves at 8:30, if the bus leaves at 8:30 a.m. and we arrive at Valley Fair at 10 a.m., the total distance is 91 miles. Is there a point in time where we must travel exactly 60 miles an hour? Don't say an answer. I say it again. We leave at 8:30. We arrive at 10. Okay? Distance is 91 miles. Does there have to be a time where we travel exactly 60? Talk with your peers. Go talk. Why? Yes or no? Why?
Yes, because you have to get up.
Well, to get faster than 60, you gotta get 60.
Yeah.
Well, yes, because they got there in
And if you are to drive on the interstate, you
like
need
it's
to drive
91
70.
miles, so if you're
Well, let's start with 55. Because that's close.
I can't put words today. A mile a minute.
You need to pass 55
Five
to
to
be able
get
to
to
go up
60,
that.
and you need to pass 60 to
You
get
have
to
to
70.
And
And then you need to pass 65 to get to 70 and 80.
5, 4, 3, 2, 1. Do you have to have traveled at least 60 miles an hour at some point?
Yes.
Yes. Why?
To get onto the interstate.
The average speed would have to be greater than 60 miles an hour at some point.
Yeah.
Okay, let's visit this because it's really important that we put this into play. I heard somebody say that you got to get on the interstate. I didn't say you were on the interstate,
Well, how else are you gonna get
and
there?
I have had cars that go 45 on the interstate.
That's scary.
So just because you're driving on the interstate does not necessitate that you are going at least 60 miles an hour.
I just thought
So
we were
assuming
talking about a
that-
normal driver.
Furthermore, I know people who drive back roads at 80 miles an hour,
Yeah.
even though they're not supposed to.
So
All right.
then they're passing 60.
So let's talk about our average rate. Suppose it was 90 miles in how many minutes? If it was 90 miles in 90 minutes, how many miles are you going per minute? 60. So that would be 60 miles an hour, right? And we're going further than 90 miles. We're going 91. So does everybody agree that the average speed is greater than 60? If the average speed is greater than 60 and you start at 0 miles an hour, you're going to have to get to at some point at least 60, right? Or you're going to have to go at least 55 miles an hour.
Yeah.
Yeah? How about 65?
Realistically, yes. According to problem, probably no. Because you'd have to accelerate and slow down.
If you're thinking about all the accelerations and decelerations, you could say most likely, but we cannot say for certain that you would have to go 65, right? I mean,
Yeah, if you run at
It
a
just might
constant
make it
speed of
lower.
like 62, you can.
right, 63 and a half might do it, right? It might do it. So we would say yes and yes, but no. So today we're learning that idea. Okay, this is very conceptual, and then we'll make it algebraic. It'll probably take us a couple days, but it's called the mean value theorem. We're going to look at it from a very simple standpoint, and it is this. I'm going to draw a graph, and I'm going to put letters A and B on the graph.
That was an awful line.
I'm going to draw a curve with those two endpoints. One endpoint will be at A, and the other endpoint will be at B. What is the output at A? F of A. What is the output at B? F of B. Everybody agree? The average rate of change is designated by the slope of the secant line. The instantaneous rate of change is denoted by the slope of the tangent line, or the derivative. Is there a spot on this graph where the derivative has the same slope as the secant line? Who's my volunteer? Risk taking. Matthew's hand went up. Matthew, I want you, like if I draw a tangent line right here, it looks about like that. Agreed? I want you to tell me where I should stop such that the slope of the tangent line will be the same as the slope of the secant line. So when do you think the tangent line slope will be the same as that? You tell me when.
Somewhere about there.
Wow.
See how those slopes are the same? The mean value theorem says that if the function is continuous and if it is differentiable over this interval a to b, then there must be some value c that sits between a and b, such that the derivative is the same as the secant line slope. So let's write that out. Let f be differentiable and continuous over the interval AB. Okay? All right, so the first question came up. It was silent because nobody wanted to ask in front of class. But let's ask it louder. What does the word differentiable mean?
Oh, I just
Take the
didn't
derivative.
know.
No, we didn't know how to spell it.
Oh, that means the ability to take the derivative, right? So it means it doesn't have any corners. There's nowhere where there's a vertical tangent. There's nowhere where it's discontinuous. Okay? So it's a nice behaving function. Let f be differentiable and continuous over AB. Okay? Then,
Continuous.
there is a value C in the interval AB. Everybody see C within AB? Such that, and this is called the conclusion of the mean value theorem, and this is what we will try to apply, such that the derivative at C is the same as the average rate of change, which is just f of B minus f of A all over B minus A.
Are we gonna have to write this out on the test?
Nope.
This isn't like that one last year that you made us.
I think that was this year.
No, that was this year.
Oh,
Yep.
my bad,
Yeah, it
guys.
seemed like a decade that we've been taking this class, huh?
Uh-huh.
This you have to memorize. This you have to know that.
But like the saying above it.
Nope, you don't have to know that.
Hills provided.
So we won't get done with this in 2 days, but we are a little bit behind in class, so I want to continue to try to utilize our time as wisely as we can. But let's just go to the basic example here. It says, consider the function below, estimate a value in C that satisfies the mean value theorem. So the idea is that we are going to look for a point or points where the slope of the tangent line will be the same as the slope of that secant line. Go ahead, take 20 seconds. See if you can estimate a time where you think that the slopes should be the same. So I've got about negative 3.5. I mean, it doesn't have to be exact, but are you people somewhere between like negative 3 and negative 4, right around there? And I got another spot about 3.5 again, somewhere between about 3 and 4. We have a number that was significantly different than that.
No, I think for the negatives, I just drew a weird line.
Sure. Try the next one on your own. Try the next one on your own. All right, what'd you come up with?
Not differentiable, so.
Hey, very good. Mean value theorem does not apply. Because you can't take the derivative at a corner. So over that interval, you just look at that spot. There's not a spot where you would find that a derivative is going to be equal to that slope. And it's because we have a corner. Doesn't apply. Everybody okay with that? Okay, so we're going to continue to think analytically here. We're actually going to flip to this page. Okay, this page right here. Okay. And we're going to look at example 7. It says, consider the following tables. Let the function be continuous and differentiable over the entire interval. And this is very similar to something you'll receive on the AP exam. Okay. A lot of times when people receive tables, they kind of shut down. It's not too bad, but it says, notice our x values, they go from -2 all the way up to +3. Okay. They go from -2 to +3. Okay. It says, does there have to be a value c in the interval -2, 3 such that the derivative of f is equal to -2? So what I'm looking for is, it says, is f prime of c ever equal to -2? Remember, according to the mean value theorem, the idea is f prime of c is equal to f of b minus f of a over b minus a. Does everybody see that we're wondering where is the average value possibly the same as -2? That's what we're wondering. Can you find a spot here where if we did like a slope formula, we would come up with -2? Like, let's just try an interval, okay? Let's try this interval here. What's 16 minus 9?
7.
7. And what's 1 minus -2? 3. Good.
Oh,
Everybody see that?
my brain's clearly not working.
Everybody see that the average rate of change here is 7/3? Is that the same as -2?
No.
Absolutely not. So, we would say, for that interval, no. Well, let's check another interval. Okay? Let's check this interval. Let's try that interval right there. What's -1 minus 16 over 3 minus 1? What's -1 minus 16? -17. What's 3 minus 1?
2.
I got 2. And that's equal to -8.5, right? Okay. Let's try a different interval. Let's try the interval as a whole. Let's try the entire interval. -1 minus 9 over 3 minus -2. What is 1 minus 9? -10. What's 3 minus -2? 5. And so I get -2. So is there a spot where the average rate of change is -2? Yes. So does there have to be a spot where the instantaneous rate of change is -2? Yes. So we would say that f of 3 minus f of -2 over 3 minus -2 equals, what was f of 3? -1 minus 9 over? Sure, over 5. So we get -10 over 5 is equal to -2. So when it says explain, our explanation is this. And then we say the mean value theorem guarantees f prime of c equal to -2. And on the AP exam, you'll be asked to invoke the mean value theorem. Okay, so you have to make that statement at some point, okay?
So when it says invoke, that's what they're looking for?
Yep, exactly. All right, so what I want you to do, I want you to skip that next question, okay? Just looking at our timing and everything, appropriate problem. I want you to now look at this question right here, letter B. Does there have to be a value C in the interval negative, should be negative 2, 3, should be 0 to 2, sorry about that, such that the derivative is equal to 5. Okay, take a while, check some intervals, see if you can come up with any spot where you have a slope of 5. Go ahead. Or 15 seconds, I'm going to ask you to come back and give me an answer. 5, 4, 3, 2, 1. Did you find a spot where there's a slope of 5?
Yes.
Where?
From 0 to 1.
Between 0 and 1. So we would say f of 1 minus f of 0 over 1 minus 0 is equal to 3 minus negative 2 over 1 minus 0. So you get 5 over 1. So yes, the mean value theorem, the MVT, guarantees f prime of c equal to 5. That's the exact line of reasoning. And trust me, I'm just exposing it to you now. We're going to come back at the end of the year. We're going to look at the mean value theorem again as we see it within the free response questions. Comes up a lot, but that would be the type of language you would use consistently. Does there have to be a value where the derivative is equal to 0 in that interval? What do you think? What is the rate of change here? X goes up by 1, Y's go up by 5. Everybody agree that the average rate of change in that interval is 5?
Yeah.
What's the average rate of change here? 3. And the total average rate of change would be 4, right? If you look at both of them. So does it ever have to have a slope of 0?
No.
It could have a slope of 0, right? Like it's possible that the graph looks something like that. You know, we're just focusing on, you know, some key points in between, but it's possible it could somewhere, but it doesn't have to. It doesn't guarantee it. So we would say, in this situation, we would say no. And if, as far as an answer, I'd say the average rate of change is always positive. Mean value theorem does not guarantee f prime of c equal to 0.
I know on some IP testing you shouldn't do like the abbreviations unless you like classify what it is.
Absolutely, you can do MVT and IVT. Oh, I just gave it away. What is the other VT we've talked about this year?
Intermediate value theorem.
What was the intermediate value theorem?
It's like the thing where if it's always between and they're both the same.
Yeah, so I'm going to connect this together because we got to differentiate between these two. This is easy. MVT is harder. MVT is involving slope. IVT is easy. IVT says if I start here and I end up here, I have to cross over every point in between, right? So here's the question, okay? Does f prime of c ever have to be equal to 0? We said no. But how about this? Is there a spot where f of c has to be equal to 0? Why?
Because it's negative 2.
Because it starts negative and it goes to positive. So if it's a continuous function, which it said it is, if you're going to go from negative to positive, you must have a spot where it's equal to 0. So notice the difference between the mean value theorem and the intermediate value theorem. If this was the question, then I would say yes. And I would say f of 0 equals -2. And f of 2 is equal to 6. I would say the IVT guarantees that. See the difference? So look at your worksheet real quick before you get going here. Because I want to show you what you should work on and what you should not work on. So today was very conceptual. Tomorrow ends up being a little bit more of an algebraic piece. If you look at 4.2, the mean value theorem, that first page has to do with the questions that we just talked about today. Okay, that first page has to do with the questions that we talked about today. The back page has to do with the questions that we're going to talk about tomorrow. Okay, and it's very possible that after I do the questions about tomorrow, I might like to start a little bit of 4.3 because 4.3 kind of takes about 3 days. If we can make it into 2.5, then I could save a little bit of a day. Do you know what I mean? So, okay, so go ahead, get started. Don't be afraid to take a risk today.
Oh, I will be.
Let us not be afraid of failure.
So, I need gas. But I want to go to Walmart.
Do you have
So-
enough gas to get to Walmart?
Yes.